probably too idiosyncratic to be useful.
That's a challenge around these parts.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams, editor-in-chief of Hackaday.
And I'm Tom Nardi, managing editor at Hackaday.
This is episode 203, Flashlight Fuel Fails, Weird DMA Machines, and a 3D printed prosthetic hand flex. This week in Hackaday News, we started the Low Power Challenge, and this is 3 times $150 DigiKey shopping sprees. The challenge is to build the coolest things you can that use as little power as possible.
Yeah, I think this is really cool. Seems like the community responds well to a challenge like this. You know, if you can strain them either dimensionally or power-wise, I think they take it very personally and kind of come out full force.
Oh, yeah? You want to see low power?
Yeah, right. And I mean, it is a little bit similar to, we did the coin cell challenge, which is very cool. And we saw some really cool entries for there. But at least, you know, this, you have a little bit more freedom now. You're not exactly limited to a coin cell, but certainly thinking along those lines wouldn't hurt.
Yeah, coin cell or solar cell, or, I mean, if you want really low power, there's all sorts of like microamp, nanoamp energy harvesting things. But that's on the power generation side. I guess but we gotta get back to the devices. Back to the devices.
Always the devices.
And I said this in my write-up, I really love Ted Yapo's Tridiled project, which was just this exploration of how little power you could use and still make an LED glow visibly. And he gave me one of them at SuperCon 2018, 2019. And it's been running ever since on my bed. And it's just so low power that it runs on a coin cell. He estimates something like 19 years on its lowest duty cycle. And I'm like, well, screw that. I'm going to put it on its highest duty cycle and see what we get. The thing is so bright that I actually have to flip it upside down. Because if you leave it pointing up at the ceiling, you can see the green glow in your room at night, which is pretty amazing. But man, 3 and a bit years now, almost 4 years, and
that's
still
wild.
Rolling on a coin cell.
That's the high water mark, right?
Yeah.
Don't feel bad if you can't make 3 years. They don't all have to last that long, but.
Yeah, well, we'll see what we get for this. I'm really excited to see. I think you're right, though. These kind of like challenges, pushing the hackers into this like minimalist challenge really does bring out the best in everybody.
Yeah, absolutely. I mean, I'm a big sucker for like e-paper and that kind of stuff, so I expect we'll see some of that, or maybe even those like transflective displays.
Yeah.
Probably some wearables. I know like Joey Castillo from the Open Book Project, he's got the Sensor Watch, which is like a replacement motherboard for, that classic Casio F9, whatever it is. I think he's got like a year plus out of, the stock batteries with a much more capable board. So it's more impressive than you might think at first. So yeah, I think there's a lot of interesting ways this could go.
And you mentioned him. He's also was playing around with driving all sorts of other crazy LCD screens, and LCDs are really low power consumption. So that's another thing you could do. Not when you have to backlight them, of course, but but an LCD on its own is, those crappy solar calculators use them, so they can't be drawing all that much power. Well, that'd be fun too. Cool art projects with LCDs, that would be sweet. Huh.
So excited, and have we even seen an entry yet? We're already salivating.
Planning what everyone should do out there.
Wow, there's 9 already.
Oh, for real?
Yeah, there's 9 entries, and this just went up.
Oh my God. Well, okay. I'm going to have to...
Okay, they're excited. They're
good. That makes me happy.
There's some pretty cool stuff already. Somebody should write these up. We should have a website where we write up interesting hacks.
Oh, that would be a great idea.
I don't know what we'll call it.
Yeah. If we did one a day, we could call it...
We'll never be able to keep that pace up.
No, never. What if there's just not enough cool stuff?
This is a journey into sound.
What's that sound?
What's that sound?
That brings us then to What's That Sound? Last week was a contest week. This week is a drawing week. I have to say that was a really obscure sound. Did you listen to it last week, Tom?
Yes, but now on the spot, I can't remember what it was. Like I know I listened to I remember everything else from the episode, but strangely enough, not that.
Well, you can give it a listen if you want to.
I was just gonna say, like, I like the drawing weeks because I'm not embarrassed, but let me embarrass myself.
No, everybody's
Let me go
embarrassed.
above.
That's
Let me
the
go
game.
above and beyond to.
That's the game.
Let me say, what was that? 21. Oh, I do remember this now. Well, I mean, not that I know what it is, but I remember hearing that from the. Is it? I think we did that recently, though. It's not like flip displays, is it?
No, it's not.
If it's not flip displays, I don't know, some kind of spark, some kind of coronal discharge.
That's what a lot of people said. Super many people said welding or like, arc discharge welding. That's totally right. Sounds too musical, doesn't it?
It's the hint. It does. It sounds a little more patterned than tapping the stick welder.
Yeah, it's all good. That was my hint. We talked about this hack super tangentially in the rest of the show, and I tried to give a clue to that, and a bunch of people actually picked up on it. But I also accidentally misled people because I gave this hint that it was going to show up later in the show, and then we talked about the CNC cutting monks of Wyoming. And a lot of people picked up on that. And so we've got stone cutting CNC machines from like fully half of the answers. But unfortunately, that wasn't it. It was another hacker, Daniel Shimu, who was the acrobat, the guy with the robot acrobatic dummy. And he also built this crazy thing that had a bunch of bike wheels, and you could press down levers that would insert cards in the spokes of the bike wheels and then release them. And so you could play them like a big crazy organ. And this was his Clappermobile. And that's what that was the sample of.
It's like the bike wheel organ.
Yeah,
I want
totally.
to put him on blast a little bit too, because I think you talked about the dummy thing last week, and he found out last week that we have a podcast, and I know because he posted he was very excited to be on the podcast, and now it's two weeks in a row on the podcast. Imagine you discovered a podcast, and it seems like every episode they talk about you on it. and you wonder like should I go back and listen to the old ones? Maybe like this is the thing they do.
Truman Show. What's going on here? Anyway, the point is that two people, count them two, got it right. One was Skull N20 and the other was the Electric Canuck. And I'm going with Skull is heads, Electric Canuck is tails, and the flip says tails. That is the Electric Canuck. Congratulations.
Oh.
Multiple cards being slapped across multiple bicycle tires being used to play music and not bridge, also known as the Clappermobile, by Daniel Shimu.
Wow. Did we write about that, or do you think they just...
I just mentioned it in passing when we were talking about other things that he did.
Oh, that's some deep dive research then.
Electric Canuck, I will get in touch with you, get you a t-shirt. Everyone else, listen in next week. We'll be playing another sound, and you will have a chance to guess what it is and let us know. Well, my first hack this week comes to us from Bruce Land, and he's a professor at Cornell, runs an electrical engineering class there that has a practical requirement that they put together a project by the end. He and his students have been regular submitters to Hackaday for at least a decade, maybe 15 years now, and they're always a source of awesome, crazy projects. And I had the sinking suspicion that some of it's because Bruce is a crazy hacker himself. And this post brings that out. This is RP2040 DMA hack makes another CPU core. And this is pretty crazy. The idea is to use the DMA hardware infrastructure on the RP2040 microcontroller, and this is the Raspberry's microcontroller, to do actual computation. And this idea is not new. I mean, he didn't invent that. In fact, we linked to the seminal paper here, which is one of my favorite titles ever, Run DMA, which we'll throw the links in the show notes. If you haven't read it, you should. Basically, the gimmick is DMA, direct memory access, is a system inside microcontrollers and actually our big CPUs too, that can be triggered by a certain condition to move a chunk of memory or move a chunk of data from here to there. And so it can be take it from memory and move it out to a peripheral. So if you want to like write automatically out to the serial buffer when it's cleared up, you can set up a DMA trigger that says, oh, it's free, here's the next byte. Oh, it's free, here's the next byte. Like that. The trick here is he's using 3 different DMAs to A, fetch data, B, kind of execute that data, and C, then loop back around and update the first one. The first DMA basically holds a pointer. So this is, you could think of, if you were thinking of this as a real computer, of being the program counter. DMA 1 then kind of fetches the instruction from there automatically and runs it. He uses some really weird things in the RP2040's DMA infrastructure that I'm not 100% sure I understand. It's called the sniffer, and it's meant for doing like CRC computations on the fly. And he's found out a clever way to turn that into basically an adder, so that in the process of transferring the memory from here to here, you can also add a number to it while it's in flight. And so he's actually got a free adder along the way here. Anyway, you should definitely look at it. He's got himself a complete Turing machine, but he doesn't stop there. He's actually written a few demo programs for the thing. One of them that's really cool does some fractally DLA. What does DLA stand for again? Diffusion limited aggregation, which is the math person's name for those kind of fractally looking patterns you get like out of Lichtenberg figures. He's actually computing these using his funny little DMA-based computer and a random number generator inside the chip. He's able to implement a simple audio rate filter or generate white noise or do direct digital synthesis. He basically pulls off quite a few little interesting programs, and he's also got a library written for it called DMA ASM, DMA Assembler, which uses a bunch of these kind of primitives that he's managed to cobble together out of instructions moving memory chunks around. So you should check that out. This is a really cool piece of work. I have no idea if it's practical. I mean, for some of the things, like for the sound synthesis, which is basically just sound playback and update a counter, that actually makes total sense to run something that simple on a little like Turing machine-esque computer like this. And he does say that he's able to play back at, when he's using an SPI DAC chip, 500,000 samples per second, which is more than enough for audio. That's pretty damn fast, actually. So that's all just running like without using either of the 2 CPUs on the chip, just spinning memory around in this DMA weird machine.
Well, it's kind of ironic too, because you got the PIO on there too,
Right?
So now you have, as if that wasn't enough, now you have another little strange processor that you can abuse.
The PIO is another possibility here, and one of the things he can do with this, of course, because it's using DMA writes, one of the things you can write out to is the GPIO pins and stuff, and there's no reason you couldn't loop in the PIOs into this whole strange machine computation architecture.
And it says has similar performance to an Arduino is kind of how it classifies it too, right? So it's like you have your RP2040 with a free Arduino tacked to the side.
That's pretty crazy.
I like to have constructive and on-topic things to say about these projects, but I gotta be honest. This one's way beyond me. This one's pretty wild. So I'll take an alternate tack, right, and just say I think I vastly underestimated the RP2040. I think when we first started covering it, because I didn't really think it was going to be that big of a deal, but clearly I was wrong. Because like keep seeing more and more stuff like this. Like people really love to harass this particular piece of silicon, and I mean I'm all for it, unlocking these new abilities and cramming it into as much stuff as possible. So I mean, seeing something like this is really inspiring. Just when you thought all the stones had been turned over, somebody finds one that was still pretty firmly planted into the ground.
And I mean, some of that's just, what else are you going to use? Your choices for chips these days are, what's cheap and available still.
That's
the
true.
ESP series
That's true.
chips and this one. My old favorite, the STM32s, are all stocked out.
Forget about
like,
it.
good luck getting a non-counterfeit AT Mega whatever. Like...
That is actually a really interesting way to think about it. Did they just really luck out to be on the scene?
Yes.
With their own in-house processing ability, whereas everybody else is struggling to get their chips made.
I think that is the case. I think they lucked into
not to
this
take away
global
from
chip
the
shortage.
design.
Yeah, with a sweet. I mean, it's a sweet design. It's dual core. It's
Yeah, it's not like a lemon that we're forced to use. I mean, it is a really cool chip. It also was very fortunate about when it hit the market.
Yeah,
but,
for sure.
Yeah, they're cranking them out. I just saw a thing. They raised the limits on like how many you can buy from Adafruit because they have so many of them. Like they're like now you can buy 10 at a clip. I guess before it was 1 or whatever they were, but now they've raised how many you can buy. So as other people are struggling to get their stuff out there, they got a surplus.
Yeah, they're not scarce at all. I mean, you can really buy however many you want, and at $5 for an already built up dev board that isn't even like bootleg China stuff, and it has a ton of memory on it. I mean, if you don't need Wi-Fi, they're a deal, and if you get one with the Wi-Fi on it, that's not quite competitive with an ESP32, but pretty damn close. So if you're used to using them and you like some of the peripherals, go for it. I mean, none of this is break the bank stuff.
I think they're enabling Bluetooth, I think, soon, right? I think I read that.
Ooh, that'd be cool.
Next month or the end of this month, I think they said they were going to update the SDK so you could actually use the Bluetooth, which is one of the things, like it's been there from the start.
That's
but, like,
been promised from the beginning. Yeah, but they didn't have the software support.
So, I mean, you spent your $4 and it only gets better with time. Well, what can you, like, where else can you get a deal like that?
Yeah. Well, it's $8 if you want
$8, you're right.
But, you can't.
But still. Well, if you spent the $4, you get the extra core that Bruce figured out.
Exactly.
So that one got better too.
Yeah, and if you haven't read it, absolutely do go read the Run DMA paper. It's about DMA as a computer being a security vector in big computers. So it's not necessarily related to embedded programming, but it's a really cool piece, and it definitely lays out the theory for all this.
Well, my first hack I wanted to talk about this week comes from Vogman, who apparently was called Vegetable Oil Guy before. I'd really like to see what he was working on previously, but this is a project to make a community-driven database of resin 3D printers. And, I think it's really interesting. If you haven't looked into it, there are a ridiculous number of these on the market. They're largely pretty cheap, probably cheaper than you're thinking if you haven't checked it out. And it's hard to say, what's good, what's bad, what's worth the money. Is it worth spending another $50 for this, that, and whatever? I'm probably preaching to the choir here a little bit, but I don't know if you guys notice the Amazon reviews are garbage anymore. You can't trust Amazon reviews because they've been hacked, and they'll be reviewing something else. I don't know how the hell it works, but you can't trust anything on there anymore. And there's infinite YouTube videos where people are claiming these things are great, but a lot of them they got the thing for free, so you kind of take that with a grain of salt. It's hard to get good, reliable info about these things. So I like the idea of just like no vanity, nobody's pushing anything. It's just you literally say, hey, here's what I got. This is my experience, and off you go. And kind of the interesting thing to me when I initially read about this, I kind of thought it'd be like a review site, right, where you could write a review. But then when you look into it, because I actually went as if I was gonna, I didn't pollute his database with with made up information or anything. But you go on there and there's all the little icons for the companies. You click one, you literally only have like 4 or 5 fields with pull downs. Like there's not a lot of room for getting creative. It's like, did the thing work when you bought it? Did you have to contact support? Did you have to come up with a fix yourself? Like, they're very specific questions, or really you'd say like data points almost. And then if you go back on the main page, it's just kind of all percentages, So on one hand, I kind of would have liked to have been able to like see actual reviews, but I can see how this gives you more of a like a no nonsense kind of approach to it. Nobody's spinning a yarn here. It's like either it was broken or it wasn't broken. Very simple, just the facts, ma'am. Yeah, he does say that there's not a huge amount of data right now, so you have to kind of take it with that grain of salt. But stuff like, any cubic, like 87% would recommend it. So that's a pretty decent metric, right? Whereas
Right.
some of these companies I have not familiar with are down quite a bit lower than that. So it's something to check if you're in the market for that, or if you already have a printer, whether you're happy with it, or maybe specifically if you're not happy with it, go
Right.
on here and put your info in for the betterment of the whole community.
I think you're right, and I like the no nonsense bit. How many had mechanical failures? How many arrived broken? How did customer service deal with it? I can't quite figure these numbers out. Like 18 of the Elegoo Mars printers, 18 had mechanical failures, 4 arrived broken, and that's 22. And 25 of them were fixed by customer service. So they fixed 3 more than were broken. And that is some awesome customer service there.
Yeah, a round of applause for the
But
customer service at
they fixed
Helico.
3 of the unbroken ones. The tale with Anycubic and with Elegoo, which are kind of the 2 most popular cheap ones, is that they have a lot of problems. Like 10% of them have mechanical problems or have arrived broken, but they all basically all get fixed, and basically everyone says they recommend them. So
And they're cheap as dirt. So I mean,
and they're cheap as
you're a little
dirt.
bit more forgiving when you paid $150.
For sure.
You might have to mess with it. Whereas compared, you go look down where they have Form Labs. There's only 6 entries because the things are cost as much as a small car. But I think it's interesting that they're only like at 67% recommended. So I mean,
Yeah.
granted, it's a very small sample size, but.
But look
it's
at
interesting.
Formlab's mechanical failures and arrived broken.
It's true.
0, 0, 0, 0, 0. Goose egg all the
Yeah.
way across. All of them worked.
But still one fixed by customer service. None of them
Well,
broken, but
again.
one fixed. It must be like the little elves that make the shoes. Like they come in while you're sleeping and fix your resin 3D printer.
That's right. That's right.
Well, you almost have to wonder, like, if nobody had a problem, why did only 67% recommend it? I guess probably in that case, it's just like I had to get a loan for this thing and I'm not happy about it.
Yeah, I think you're right. It's the price, right?
Yeah,
But
right.
Yeah, but you're paying for something that works off the bat.
This is true.
And like you could put it on your desk and make it run. And like the other ones, it's like maybe it needed a little this, maybe it needed a little that.
That's a good point, because the Prusa, which is also quite expensive, is again 0 failures, and still that
Look at
one,
One fixed by customer service.
How do they do it? I gotta. So that's an interesting thing you can pull out right there. The more expensive ones clearly have lower out of the box failures, but
Yep.
you're paying so much. If you could buy 2 or 3 of the other ones for the same cost, it's kind of hard to get excited about. What is this? 300 entries maybe total or something.
Yeah.
Looking at it, but as we get more and more, he even says we need 10 times more before he'd feel comfortable making a strong argument for anything. So like I said, if you're out there, put your info in. If you have multiple printers, even better. You could do a couple of them, especially if you have one of these ones I've never heard. Like one of the companies is just called Longer. You're sitting around the boardroom. What do we call a company? I don't know. Could this meeting be any longer? Oh, that's it. That's what we're gonna call it. Sprint Ray sounds pretty cool, but I haven't heard of them either.
Definitely want a Sprint Ray.
Ray, yeah. That's like a Fallout weapon, I think. You get that.
All right, my next hack is DIY capacitor leakage tester with a professional finish. And this is a project of many by Manuel Caldera. This is a capacitive leakage tester that he has mounted up along with a whole bunch of other kind of DIY measurement equipment up under his bench. And that's kind of what's the coolest part of it for me. He's an amateur radio fan, and a lot of these measurement tools are kind of amateur radio specific DIY classics like an antenna selector and a pi attenuator. This one puts a voltage on a capacitor, you can change that voltage, and then it measures how much leakage current is passing through the capacitor. Ideally at DC, of course, that is 0 microamps. But in any real capacitor, some current is going to sneak across the gap. And that's what he's measuring here. The measurement device itself is really easy. It's a microammeter with a switchable shunt on it, so you can make it read in microamps or milliamps or whatever just by changing a resistor you put across it. That part is not particularly interesting. But what I love is the way he made these, and they're all made out of C-shaped aluminum extrusion channel, and he has them clip into another rail. Maybe it's a DIN rail? I don't really know. Under his desk, and so they all slot in. But because they're all made out of the same extrusion, they all have the same size, and he's drilled nice holes in them, and he's put nice labels on them, and he's put a little 90-degree bracket on the backside. So he just kind of clips the front in, screws it on the back, and it's strongly, firmly mounted up under his desk, matches all the way across the board, and I can just totally imagine having a good time making a whole bunch of crazy bespoke measurement instruments and like just lining my desk with them. That would be heaven.
Not to take away from the capacitor leakage tester, which is a cool idea, and it's funny, you know, we've written so many posts about recapping and bad caps. I don't know that I've ever actually seen somebody have a dedicated capacitor tester on their bench, but it makes a lot of sense.
Right.
But not to take away from that, because that, you know, that is an interesting idea. But yeah, you're right. Like, it is so professional looking. Like, it really, really looks like this is like some underwriter's lab thing. Like, they're so uniform, and that's not easy. I mean, probably anybody listening knows making a nice front panel could be the hardest part of a project. Because, you know, getting everything printed, lined up. It's almost like, you know, you came up with the look ahead of time. You know, which is cool. Like, you're like, okay, this is how I'm gonna, and like you said, they're gonna be the same little C channel deal. They're all gonna have the same font, and then you just kind of roll with it. You know, I really appreciate that kind of forethought. And then I noticed even like you see like the little magnetic rail. He's got all his like side cutters on and stuff like under it. Like this is a guy who really appreciates, you know, an orderly workspace, which
he's got a cleaner desk than I do.
Yeah. I absolutely do not, you know, I'm not going to enter any competition with him in terms of cleanliness, but I respect it, right?
I really love this mounting idea, and he must have bought like 1 meter or 2 meters of this funny C channel and just cut it up. And then he's like, hey, I'm going to use this for project cases.
Now, I won't lie. I picked this next one because it reminded me of Kerbal Space Program, and I think probably a lot of people clicked on the link because it reminded me of Kerbal Space Program. But this is one Dan Maloney wrote up about a teardown that Ken Sharif did for the Globus, I guess you would say, a Soviet-era analog space computer. Like, analog, that's right. There are gears, if you can believe it. There are little gears and weird cone drive things inside this, and the idea is that the cosmonaut just sees a little globe inside of this unit, and it rotates to show where the capsule would be if it was, you know, in a straight up and down line from orbit. You know, the more you read about it, the more fascinating it is, because you really had to, like, I mean, this is old school stuff. This is very old school. Yeah. Like, you had to, you know, enter in the speed and everything, and like there's a day-night thing. There's just kind of like a little filter that comes out. Like, it is amazing that, and, you know, this isn't even to knock the Soviets or anything, but it is amazing that we sent people to space with this kind of technology. You know, and it's certainly the U.S. was doing similar stuff, so it's not like I mean, how they had periscopes on the first Mercuries, because, you know, there was no closed circuit camera that they could put in there small enough, so they had like a little submarine thing come out if they wanted to look over the nose. It's really cool to see how they solved this. It's actually easy is not the word I want to use, but what you read about, like, the idea is that, you know, the little globe is tilted at whatever 51 point whatever degrees, which is like where they launch from, so that it's already at like the inclination that the capsule would be at, basically. So you really just need to rotate the globe, and then it sort of automatically, like, that's the core concept, right? Like, if you tilt the globe to the right angle of their orbit and rotate it, it'll more or less show where they are. It's just a matter of rotating at the right speed, and you can twiddle that with the knobs. You know, that's not just to have just as an illustrative thing. You can say, hey, you know, Dimitri, where are you at? Oh, I'm over Cuba or whatever. But then it also would do stuff like it could calculate your landing position, admittedly within a very large, and I think it said like 150 kilometer circle. But still, I mean,
that's not bad.
For the time, I guess that's not terrible. But you could say, like, okay, if I hit the button now, where would I be? Where would I end up being? And I think you do have to, like, enter the re-entry angle, because that's going to adjust, you know, that's going to change how much lift you have coming through and stuff. But you could see, certainly for like an emergency purpose. I mean, imagine you were up there, you were cut off, you can't communicate, and you say, okay, well, hell with this, I'm hitting the button. You
Right.
can at least make sure you're dropping in the right continent. Don't land at those pesky Americans that might kidnap you. I mean, there is the one picture on the write up, but you really do have to look through to the website. All his images. There's so many cool little pieces inside of this thing.
Yeah.
I imagine that someone will look at our technology with the same awe in the future, right? Because you look at this and it looks like it's a fantasy. Like this must come from some other world because it's so alien looking in how it's put together. But it's just at the time that was the easiest thing to do, especially with the computer hardware was at such infancy back then. That this was the most reasonable way to do it. All these little belt drives and custom gears, and the wild thing is that it's because of that, I guess, a lot more approachable in a way.
Yeah.
Because we've covered the stuff like the efforts to get like the Apollo guidance computer modules working, and it's really difficult because that's its own thing. But at least this you can look at, like, okay, well, this gear spins that, and that turns the globe, and it all makes sense in a very visceral way, which is cool. And yeah, just to think that this was at one point standard issue, and I think in the write up it says up till 2002 they were using them, which is pretty wild too. But I guess hey, if it works. It says
right.
like the one major complaint was that it could only, and it makes sense, right? It could only do circular orbits because again, the little globe is kicked off to the side at the appropriate angle, and then it spins, but the globe is round, right? So if you're trying to do like an elliptical orbit or something where your ground track is not going to be consistent like that, it quickly becomes useless. But
you'd need another motor to wobble the Earth back and forth, and you could do it. You could do
the
it.
motor, the wobble motor.
Just needs one more degree of freedom.
Right. But back in the day, all they were doing were basic little circular orbits. So you could, for decades, this would have been more than enough for your guidance purposes.
No, it's fantastic to imagine this kind of alternate reality. You're in space with an actual spinning globe, and that's how you're going to get home. But what I love about Ken's write-ups, and this one in particular, but basically all of them, is that he goes through all of these little details that if you just open this box up, you would have missed. But he picks up on all of the cool details because he is interested in completely reverse engineering this thing and understanding every worm gear and every swing arm and every cam and follower in the whole damn thing. And that really comes across in his writing, like that enthusiasm, but also that attention to detail is just so great to read. And Ken's blog, always a pleasure.
And then Dan mentions at the end that looks like Curious Mark was involved, as he's wont to be. Could be a video in the future for this, which would be really cool. One of the interesting details was like, it's not a full teardown because the thing's just so complicated. They weren't really feeling confident about putting it back together. Like, imagine how complicated it has to be where these titans of the teardown are like, yeah, you know what? I ain't taking this thing apart.
Back up a little bit.
Let's just take some pictures with the lid off and call it a day.
Well, from the extraordinarily complex to the relatively simple, my last hack today is Ian Davis's designing a simpler prosthetic finger. And it's actually a set of prosthetic fingers. I don't know if you remember Ian Davis's YouTube channel, but we've covered him before. He has all 4 fingers on his right side amputated. And so he has been working on making prosthetic gripping hands. And through a great video series that I know we covered before, he was doing the machining to make an aluminum hand for himself. And the mechanism there is really simple, actually. He kind of, bends his hand at the wrist, and then this couples to a thing that's attached to his forearm that then makes the fingers grip and ungrip. And this is a really simple mechanism, in air quotes, that gives him great ability, right? Like it lets him grab onto stuff, which is what you kind of really need to do with your hand. And so I love his builds. And the earlier series where he was working on this aluminum one is really cool because it's got a lot of heavy machining, and he's worried about getting all the gears right and making sure that he gets a finger that bends and grips just right, and that he can also use in conjunction with his thumb, which he does have. and that it's light and that it's strong and all of this. In this video, he's turning his attention toward 3D printing because he wants to make this kind of thing accessible to other people who are in a similar situation but don't have access to a metal machine shop. And so I think that's really cool in and of itself. But what I really like about his videos in general, and this one in particular, in contrast to last week, where we were kind of talking about the engineer savior trap and what happens when, people are like, I want to fix this problem for deaf people, and deaf people are like, hey, we don't have that problem. We don't even want it fixed. This is like the polar opposite. This is the guy who is missing his fingers working on a device for himself. And he really knows what matters when you're trying to do this. He's like dog fooding in the extreme. He lives with this device and has been living with the various versions of his plastic one. And it's really neat to see the kind of insights he brings to it because he lives with the problems. Like, he's talking about the ratio of how much he has to bend his wrists versus how much action it gets on the fingers, because there's obviously a leverage issue there, right? Like, it's geared down, and that gives him mechanical advantage, which of course you want, but it makes the fingers slower, which you don't want. And so he talks about trade-offs there. The fingers on his metal hand are articulated all the way, like all of the different phalanges, ? He uses a lot of like technical anatomy terms that I've totally forgotten. The last bendy part, the last digit on your fingers, bends over in his aluminum ones, and he sacrificed that for simplicity in the plastic one. But then he's also got a TPU like fingertip that goes on the top of it that helps it grip. And, just things like this that I wouldn't have thought of, maybe after using it for a while, I would have eventually figured out. But he is probably the expert in building prosthetics for this kind of hand injury, right? Because he's doing it himself. He's iterating on it. His metal one is like in 8 or 10 revisions now. I don't even know. So if you want to look to prosthetic design and how to think about the mechanics of it all, I think he's actually doing the rest of us a great service by sharing his work. Because, as a person who has all my working fingers, I don't have the insights that he does. And it's really, really cool of him to share it with the rest of us.
I'm a huge believer in 3D printing. You know that. I have
Yeah.
within arm's reach. I have like 3 3D printers right now as we record this. But there's probably no application more befitting and maybe noble than doing prosthetics. And we've seen so much activity with that, and it's really, it's life changing. I mean, there's no other way really to describe it. And the ability to come up with your own, like you're saying here, this is not somebody did this for him and he's like, oh yeah, thanks guy. You have no idea what I need. And so you gave me this go gadget, crap. This is tried and true, but you could do that on your own. You could do that in your home, like you said, without a machine shop. To a degree, you could scale it up and down for different.
Absolutely.
You could have one design that you just you go into Slicer, you scale it down by X amount of percent, and then a kid can use it. It's incredible possibilities, and especially when you consider not that long ago, you might just be beat if you couldn't afford one of these high tech prosthetics. You made do. And that was it. Like there was no real option, And now to open this up to so many people and to be able to do it so affordably is incredible. I've gone to several, like the East Coast Rep Festival, and there's always at least one table with people showing off this kind of thing, and it is super inspiring. And not to knock people who are able making these for, what I mean? Like if your side project is to make these things and you have all the access to your limbs, I'm certainly not trying to put your efforts down. But like you said, it is more, well, you put it perfectly, really. It's designed for a realistic need. It's not like somebody assuming what a person would want. I mean, this is the real deal, and I'm happy if you need this. I'm very happy for you that the technology is out there and so accessible in a way that it never was before. you know?
And you totally hit it with 3D printing because, like Davis points out, with his metal hand, he can make that because he's a skilled metal worker. If you have a problem like this, you can't make that. You know, you're not going to like learn metalworking just to make this prosthetic hand, but you totally can get 3D printing done. Like that's a much simpler startup, and it's also so much more customizable, and then that puts the power in the hands, of the people who need the hands, right? He points out that because this is 3D printed, he was actually able to scale it up through, a couple iterations to exactly match the size of his other hand. And that's something he really likes more about the plastic one than he does about the metal one. And like you say, if a kid needs one of these, scale it down and boom, off you go. And I do think there is something there that the 3D printing brings to this in terms of easier access, easier customizability, everything like that puts the power to tweak around with it again in the hands of the people who need it. And that alone is super awesome. And I think we see some of that through enablingthefuture.org and the Enable Alliance are these two groups working toward getting 3D printed prosthetic designs to the people who are actually using them and helping them out by either helping them with the printing or helping them with cooperative design and things like that. But I really am stoked the most when I see people who have the problems able to solve the problems and other people helping like this. Like, here, have this design. This is a great starting base. But like maybe you need it to be different here or different there. You can tweak it, fix it up yourself. And I think that's just so fantastic. And it's giving the power to the right people. And I love that.
And it's an interesting crossroads too with open source because you need the designs too. I mean, it's one thing to be able to make your own hand or whatever, but then to be able to put that out there and say, hey, not only are you allowed to remix this, we encourage it. Like we want to see that, and we want to see any kind of variations you can come up with because then someone else down the line might be able to use that. So it's kind of everything that's good in the hacking and making community distilled down into one project. My last hack this week is Secure LoRa Mesh Communication Network. It's funny, some of the comments said that all these LoRa mesh projects remind them of the XKD comic about making new standards, and then you just end up with another standard. And it's true. We've seen a lot of these kind of LoRa mesh things, and they all have their own little tweaks and their own whatever that they bring to the table. I think what I like about this one is it seems more approachable than a lot of the other ones we've covered. On the hardware side, you just need a Raspberry Pi 4, which admittedly is an increasingly tall order these days. But eventually, I'm sure eventually you'll be able to just buy them for regular price. It's a Raspberry Pi 4 with an Adafruit LoRa radio, shield, bonnet, whatever their nomenclature is. And that's it. You can put it in a 3D printed box if you want, but that's it. There's no soldering, there's no PCB. It's just two little modular things you plug together. And the cool deal to me is that this isn't like, we've seen like LoRa communicators and like little handheld deals. This is meant to be used on your totally normal off-the-shelf computer. So it actually hooks up to the computer over Ethernet. And you don't get the internet, which is important to note. You're not going to, be browsing the web over this. But the software on the computer side can talk to the radio over Ethernet. And, the demonstration shown here is secure messaging. There's like a little IRC looking kind of window where the different nodes can communicate. I should say that this is not like a complete turnkey system. Like I was actually just looking at this before we started recording. I don't think the software itself is out yet. I think that Thomas, the creator, is he shows it, there's screenshots, but I don't think there's a download, and it looks like it's for Windows only, so it might as well be on the moon for me. That's not the important thing necessarily. What I really like about this one is how well documented it is. The documentation is phenomenal, and it really goes into every aspect of how this works. Like I said, the hardware bar is low, the documentation is here. It might not be ready for prime time or necessarily your application, but I think if you're considering doing something like this, this is a great jumping off point. This is definitely something you should read up on, you should look at. And even if you're not going to build it yourself, I mean, just if you're curious about how this stuff works, I mean, there's even got like an appendix with references and stuff in here. This is an exceptional piece of documentation. If only they had, footnotes and bibliographical records like this one. I mean, it even has like accessed on certain date. I think this might be a Wikipedia editor in his downtime, but. But yeah, awesome documentation, very low bar for entry. Maybe it's just waiting on somebody to take up the challenge of making a multi-platform little software component for it. The advantage of this kind of thing is always, natural disaster or something. You could have this like mesh network that doesn't rely on any existing infrastructure. So if you could do something like that, that's easy to use for the average person, I think you could really have something potentially game changing.
First of all, I love these low power LoRa messengers, and people sending directly radio to other people is like, it's what got me into ham radio. I'm all down with this. What's interesting here and what always shows up in the comments is someone says, why don't you use this? Why don't you use that? And Meshtastic is one that always shows up.
Yeah.
And I think at some point we do have to worry about the problem of interoperability, and when you need to use it, will anyone else be listening to the exact same way that you're sending it out or not? And I mean, it's a network. There's what the economist in me wants to call network effects here. The more people using the same protocol, the more valuable that protocol is. And I don't know what the deal is with Meshtastic, actually. I'm looking into it right now. Is it an open standard? Can I build my own? Meshtastic is an open source project available on GitHub, blah, 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 blah. So you could probably, if you don't use exactly Meshtastic, you could use your own device that nonetheless would interoperate with it. I think that's an extra strength. If you're just thinking about using a communicator for you and your family or you and a small number of people, everything is fair game at that point in time.
Right.
But if you're thinking about it for some kind of broader communication and you want to, especially in a mesh, you want to piggyback on other people who you don't even know, then everybody has to agree on a common protocol. And that's what worked with APRS, and, that's what will work with some kind of encrypted LoRa something, I hope.
Yeah, and if you are talking about a natural disaster or something like that, you really you can't be fiddling with mine is this one, and I got this version, and I bought this one from Adafruit, and yours is from SparkFun or whatever. Anybody can go buy a CB radio and know that they'll be heard, even if they don't know how to use the thing. Just squeeze that button on the microphone and call for help. It has to be super reliable, and everybody has to be on the same channel, no pun intended.
Yep.
And that's kind of where you get into, like they were saying in the comments, that every time somebody creates a new one of these things, thinking theirs is going to be the end all be all, they just kind of muddy the waters even more.
Oh, I think people are making them because it's fun to make them. I don't know if anyone is planning for global domination here. I think there's plenty of room for that. I'm stoked to have my own personal projects, right? So don't, we don't have to knock it. This doesn't have to be the one that takes over the world.
No.
But I do think there's some value in one kind of open protocol taking over the world, as long as it's the best one.
But that's cool. Just as a illustrative thing that shows how it works, I think it's really, there's value in it. And it's, like I said, very well put together, very well explained. Read it. You're going to enjoy it.
My first quick hack this week comes from Siren Elisa Wilhelmsen. It is Knitting Clock Makes You a Scarf for the Next Year. It's a sweet hang it on your wall knitting machine that slowly, day over day over day, makes a long tubular scarf for you. This is meant to be an art project, and so it's not quite as well documented on its insides as I would like it to be, but it's still a pretty crazy cool idea. Next up, Michel, Minimalist Homebrew Hardware recreates arcade classics. And this is a group of 5 or 6 little single game machines that he's made, each one of them playing like a snake, and then there's a Flappy Bird-esque game, etc., etc. He's coded them all up. They're just sweet little single-purpose things, but they look like lots of fun. And last up, Matteus Stern, Floppy Photography making an IR filter from a 3.5-inch disc. Apparently, the little things on the inside of floppy disks are transparent to IR but block visible light. That's what he's doing here. He cuts up a little piece, stick tacks it on the inside of a lens, and takes some photos. Not quite as sharp as the professional infrared filter he's got, but it looks like a great way to dip your toes in the water if you want to play around with it.
So my first quick hack this week is Bend It Like a Carpenter. This is a video from Totally Handy, and it is a topic we don't often see on Hackaday, and that is advanced woodworking. And, I wrote about a woodworking project like a week ago, and I started off with saying, like, we totally respect woodworking. It's awesome, but just most of us don't have the stuff necessary to do it, so we tend to, stick to the sparky bits. But, when you watch a video like this, it's really amazing what you can pull off with wood and the tools to work with wood and the knowledge to operate said tools. And, one of the kind of like the key things here is like making these flexible, almost organic joints in a piece of wood. And once you've seen it done, it's almost like I could do this, like you get that impression like, oh, I get it now. You have the table saw just set just so and alternate it. Do I have the equipment to do it? No. Do I have the experience to do it? No. But these people do, and I appreciate it, and I appreciate them sharing it with us. And, maybe we'll have to open our eyes a little bit more to some of these woodworking topics if they're going to keep making stuff this cool. Next up is cassette player cup holder is a useful but risky idea, and the reason I picked this one is accused is probably the wrong word, but I have seen it said that the average project on Hackaday anymore is quite a bit more complex than they used to be in the good old days. That's a product of incredible tools and stuff that is available to the average person, so naturally they're making more complicated stuff. But there is part of me that does kind of yearn for that simple little, 15-minute hack that was maybe more common back in the black and white picture days. And this reminded me of that. It's a 3D printed single piece, it's a circle with a little fork that just jams into the cassette deck of your car, which you're not using anyway because you don't have any tapes and the thing's probably broken. And you can put your cup holder there. Should you put a cup of hot liquid in a 3D printed object that's jammed into the cassette player? Maybe not. At the very least, it gets people talking. And my last quick hack is we turned expansion card for broadcast monitor. Now, this is certainly pushing the envelope of a quick hack. This was definitely more detailed than many of the other ones that get put in this little roundup. But the idea here is that, these old games, Wii, N64, Super Nintendo, these ones that were made kind of before the modern high-definition era, don't look good on a brand new 4K TV. Big surprise, right? They were made for the blurry CRTs of the 80s and 90s and even early 2000s. But those are very hard to find, especially ones that are in good shape. And if you're a hardcore gamer, though, if you're into these old games, you can get broadcast video monitors, which were the kind of thing that you'd have in a video rack and you'd watch the output of the camera when you're making a show or whatever. These things are super high quality, lived a relatively sheltered life because they were mounted a thing, and you can get them on eBay for, not cheap, mind you, but you can get them on eBay, and, they're some of the best CRTs around. One of the features on this particular one, Shank Mods had, is it had a modular bay where you would put in different video sources. So they took a Wii and cut down the motherboard. This is a thing we've covered before called trimming, where they kind of cut away everything that's not necessary to be a Wii, and put it on one of these modular boards and routed the audio and video and all that. And they've created this perfectly modular Wii that just plugs into this expansion bay on the TV. There's controller ports on the outside, and you're off to the races playing. And, this is kind of just a one-off, but it really makes me think, is there a future to this? Could we one day see all the classic consoles converted to modular devices for these broadcast video monitors? I think they're probably a little too expensive and rare for this to be in every gamer's living room, but one can dream of being able to have a rack-mounted video game collection that they can switch in and out at will.
All right, it's time for our Can't Miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I'm going to pick Al Williams's Ask Hackaday, Do Kids Need 3D Printers? And the answer, of course, is yes to that. But the question is, do kids need special kids 3D printers? What inspired this article was back in 2016, Mattel, the kids' toy company, had thought that they wanted to enter the 3D printer market with a, colorful 3D printer aimed at kids. And it got delayed and it never came out, and et cetera, et cetera. But the question is, do kids need an easy bake oven version of a 3D printer or not? And Al kind of argues here that basically, the hard stuff about 3D printing is probably too complicated for the generic 9-year-old. And the easy stuff about it is stuff that you can kind of help them with anyway. And I totally agree with him on this. Like, my son has just started messing around with Tinkercad. He's 8, by the way. And Tinkercad is an awesome, gateway drug into 3D modeling. Like, you can move blocks around and then say, here, Dad, print this out. And that is a perfectly reasonable and awesome interaction among parents and kids. Here's your own printer. Oh, yeah, the filament's not extruding right. You're 9. You have to debug that, Did you use your calipers to figure out the right extrusion ratio? Why isn't it sticking to the bed? There's all this crap, even with a regular 3D printer, that kids probably don't want anyway. And then if they do, what they probably want is something that works straight out of the box. So what they probably need instead of a dumbed down 3D printer is the opposite. They probably need the heavy duty industrial machine that comes with a $5,000 a year service contract that just works when you hit print, right? And that's basically my role in the whole thing. I'm the guy, I'm the tech who comes in and makes the machine work for the 8-year-old kid. But I think it's a neat idea to make a kid's 3D printer. But I think kind of no 3D printer, but access to a 3D printer is probably actually what kids need.
This is a fascinating full circle thing for me, because this was coming out right around the beginning of my tenure with Hackaday, actually. I remember talking to Mike about doing an article about this and never doing it, which I guess is for the best because the thing never came out, right? But I was actually pretty excited about this thing, and I think, credit where credit's due. It never came out, and we were actually just talking about this. It's possible the hardware never existed in the first place, because contemporary images and press releases, they're all renders, clearly. So they may never even have had a real printer. Credit where credit is due. If you read it, they did have a lot of this stuff kind of considered. Things like the door would automatically lock once the print started, so you couldn't open it up. The nozzle was supposed to retract into the thing somehow, so there would be no hot nozzle to touch. As early as this is, a heated bed wasn't even necessarily a given. I mean, if they were just doing PLA, I used a non-heated bed with PLA for years.
Yeah.
So I mean, you could have done it. It's not necessarily the death trap you think it is. If you had considered it, if you could, like I said, it had the locking door, treat it like a microwave, right? It turns off if the door opens. Could they have done that for $300? Like you said, you kind of need a lot of instrumentation that we're only just now starting to get. I mean, you'd need automatic bed leveling for a kid's printer, but again, maybe the hardware never even existed, so it's kind of whatever. Debating that is sort of pointless. But what they did release, and this is the thing that I wish I still had, at the time they did put out the software, and it was an Android app, and Mattel had released the thing because they said they wanted the community's input. And the app was really cool in that it was all modular stuff.
I remember you talking about this.
Yeah, the kid wasn't expected to actually do CAD. You would be like, okay, you want to make a little action figure? Well, these are the legs and these are the feet. And there was 3 different kind of feet and 2 different kind of legs. And they all use these ball and socket joints to connect to each other. So a child, even if they were, just barely able to use the touchscreen, they just had to drag these shapes from a library onto the virtual bed, and then it figured out placement and making sure, everything was just so. And I actually had my daughter, who at the time was probably 5 or 6 or whatever. She made a couple things, and the app just spit out regular STLs, so I was able to print them out on my printer bot at the time.
Oh, how
Again,
cool.
I was the guy, like you said, I was the guy who actually had to figure out how to print the thing, but she was able to make something in the app and see it, and she was very impressed. So, you know, but again, I was that person that facilitated the actual, you know, STLs getting printed and making sure. I remember very distinctly one of the things they had on there, because it really even impressed me, is that, I guess it's like an outdated mode of thought now, but there was like a girls and boys section when you started the app. In the girls section, they had all jewelry stuff. So she made like a heart pendant on a printed chain. And the printed chain blew me away because it was like, you know, it had automatically generated supports. So that, and like each link was at 45 degrees to the other one, you know, and it made an actual like nice necklace chain that was printed, and I was just as impressed as my 5-year-old daughter. I was like, wow, you know, this is pretty wild stuff. I think they had a lot of the pieces were there. Clearly, it didn't come together, but I do think they put a lot of thought into it, and I think it could have been cool. Al mentions it in the write up. You know, this would have been an entry in the ThingMaker series of toys, which goes back to like the 60s. You know,
Right.
where you would be able to squirt molten plastic into these molds and get little dudes and stuff. So like they kind of were already pushing the envelope in terms of safety. They were already squirting hot plastic. So this was, you know, a more logical evolution than you might think otherwise. But you know, if you look at the picture that's on this article, you can kind of see what I'm talking about. All the parts on the table have these little standardized ball and socket joints. You know, the one kid's got a skeleton, and the other girl's got, you know, a little kid with a ponytail. They would click onto the same body. So, like, they did really think a lot of this stuff out. I don't know. I mean, I would be cool if you know, if there may be some dark corner of the internet that Android app is still floating around. But, you know, I'd like to play with it, you know, now and see what you can do with it.
Oh man, I think you hit it though. I think it's the software. When I said, you know, my son messes around with Tinkercad and I do all the hard stuff. Tinkercad's kind of a little bit that way. It's, you know, drag around cubes and cones and things like this. But this is that plus, you know, a mechanical fastening system plus a bunch of cool templates like skeleton heads and unicorn horns and things like that. And
Yeah,
that's what's missing is like the software layer. Why don't we have a good app like this? Like this app sounds absolutely fantastic for that purpose. This app sounds like what we need to have an open source equivalent of. That is just kind of a library of interoperable parts that kids can drag and drop and put on each other and make a crazy thing out of. Dude, that's genius. We need to redo this app for them.
Let's do it. Looking at the picture, the girl in the picture is wearing the little heart pendant that my daughter did. You know, man, it's not impossible. I might still have it. If I can find it before this goes out, I'll put a picture in the show notes.
But that's what killed.
Cool.
So then this is what killed them, right? This is Mattel is like, we're gonna get into this. We'll get somebody to write this really cool software, and that will help us sell this device. And then they're like, they probably really didn't want to enter the software driving hardware sales game and just bailed out on the whole thing for economic reasons, which makes a ton of sense, I think, from Mattel. Boo to that, but it doesn't mean it makes sense for the world. The world needs crazy kids' toys.
I mean, this is so early. You didn't even have a lot of, like, I think this is probably like on Android 2 or something. But, like, when you said, okay, I'm done, I want to export the STL, it started an FTP server on your phone that you then went to with your browser to download it. Like, it was so wild. And, like, this, you know, probably the printer would have been the other side of that equation, right? That the printer was probably going to be set up to look for an FTP server on the local network and grab the thing. But man, if I could find it, that'd be cool to do like a modern review of the ThingMaker app, because I do think they had some really good ideas. And if anyone from Mattel is listening, maybe just put the app out there as open source for the community. The kids need it. Do it for the kids. Well, because no one knows me better than myself, I picked my own article to talk about this week. But in all fairness, it is a timely thing because this is about an ongoing issue with NASA's lunar flashlight, which I start the article off like you'd be forgiven for not hearing about this mission before because there's just so much stuff going on now. It's really wild, especially like if you're into space like I am. Like every week there's something cool going on. It's a good problem to have, right? That there's so much stuff. This is a small CubeSat that was sent towards the moon back in December with several other vehicles, because that's what we do now. And the idea is that this is to look for water ice deposits, which is something that they're fairly sure exists on the moon, specifically in craters. There are craters in like the polar regions that, as far as we can tell, have never seen sunlight since the dawn of time. Accordingly, are very cold and would be the place to look for deep frozen water. But they're so dark that we can't see inside of them, hence the name NASA flashlight. As an interesting aside, I talk about when I started researching this is one of them NASA projects that was originally much more like Jules Verne than the final product, because like it was literally supposed to be a giant reflector in orbit around the moon that would shine a light, like literally shine a light. That's why it was called flashlight, into the craters that they could then do spectral observations and stuff. And they said, it was going to be, I think, a 80 square meter reflector could illuminate a spot like 1.5 kilometers in diameter on the surface. It was like totally sci-fi. I mean, I think that was actually one of them things that was, back in like Victorian times, they'd be like, well, what is life going to be like in the year 2000, and I think one of them was like, there'll be mirrors in space lighting up the streets so that we never have to go out in the dark. This was like, total comic book villain stuff. The reality is not quite as exciting. Achieves the same goal. It actually uses 4 infrared lasers that shoot down, and the concept is the same. They shoot straight down. They illuminate now a spot that's only 35 meters in diameter. And a telescope on the craft looks down and checks the what wavelengths are getting bounced back, and you'll be able to figure out what the surface composition is. But that assumes it gets to the moon in the first place, and that's kind of where we are right now, because this is the first spacecraft to use a new green quote-unquote propellant outside of Earth's orbit. Usually these kind of things would use hydrazine, which is a horrendously nasty, I think it does neurological damage on contact or something. It's one of the nastiest things in aerospace. So they've been trying to find something that's a little less killy. The problem is, like, so if you have one of these spacecraft now, the lab that builds it, right? But then it has to go to a secure facility to actually be loaded with propellant, because you can't just trust anybody with this horrendous devil liquid. So the idea with this new green propellant is it's no more nasty than any number of things you'd have in an average laboratory. So they could load the propellant where they build it. And that greatly simplifies the whole workflow to get these things loaded into space. And with the rate that they're moving them now, we kind of need these sort of streamlines. Anyway, there's a lot of excitement about this green propellant because it's not the nasty toxic thing. But here it is at its big debut mission, halfway to the moon, and it doesn't seem to want to work. And there's 4 thrusters on the spacecraft. 3 of them are underperforming, which obviously, hints towards some kind of a systemic issue. It's not just, one bum thruster. Right now, as of the latest update from NASA, they're still not sure what the issue is. They are operating under the assumption that the fuel lines are clogged, so they're not getting the proper measured amount of propellant to the thrusters that they expect. Basically, they're hoping that if they just run the thrusters for longer, they can kind of compensate. If they're only doing half the thrust they're supposed to do, you run them twice as long, and hopefully you get there. But that does assume that the situation doesn't get worse, or that they don't clog up completely. Like I said, it's early yet. There's no exact answer for why this could be, but there's a lot of first-time flying stuff on here. They did a 3D printed fuel manifold, which, is very clever because you put integrated channels for all the liquids, but, did something go wrong in that? I mean, it'll be interesting to see if they can figure out what the cause is and what they can do. A lot of interest in getting this new green propellant working, so I'm pretty confident they're not giving up. This is just one of those learning experiences that will maybe change the design of the future spacecraft, but there will be more.
That picture you included was just perfect. Like, I had no idea that the thrusters were that small. That is
you know what?
terrifying. There's a dude's thumb there, and like when I see thrusters,
yeah.
I'm like imagining some kind of Imperial Star Destroyer scale something going on here, and these things are like smaller than your pinky fingernail.
That's the whole reason I put that picture in there, because I was so amazed.
Thank you.
By how tiny they are. I was looking at it like, that can't be, but then I even looked up, like they have an exploded diagram of the thing, and like, yeah, those are the primary thrusters. They aren't like some little rotate 2-degree thing. Like, that's it, but the whole thing's only the size of a briefcase, and you're frictionless or near frictionless environment. It doesn't take a whole lot.
Just needs a little shove.
And I am fairly sure even the thrusters are 3D printed. There's conflicting, so I didn't put it in there one way or the other, but by the looks of them, they also look kind of 3D printed. So I'm sure would be very difficult to inspect it, right? Like, it makes total sense to print these things in one piece, because if you're going to do it with traditional plumbing, all the couplings and stuff, they all add weight, they all take more space. That's like, so you could do this print in place thing and get rid of all that. But, can you adequately inspect it afterwards? Do you have to like x-ray the thing, or do you have to like run borescopes through it?
Yeah.
You can't just take the pipe off and look at, hold it up to a light and look through it like they probably did back in the day.
Cut it in half and see what it looks like on the inside. I don't know how you do. Yeah.
So I think that will be interesting. Like, they probably have a ground spare. They always do, multiples of these things. So I wonder if like somebody is cutting one of them things in half right now and looking at like, well, what does the inside of these channels really look like?
Man, who says NASA doesn't take risks? Like, half the time we're like thinking that they, only use tried and tested technologies and all this. And then here's one that's like, we're going to go shine light on the moon to find water, and we're going to try a new propellant, and we're going to try new thruster technology, and we're just going to do it. Who says that it's just the private industry people taking risks and breaking things?
If it wasn't so cheap to shoot the stuff into space now, this might not have never happened. Like, this was a secondary payload on a Falcon 9, and a Falcon 9 is already the cheapest way to get to space. So like this, riding coach on the cheapest rocket is very. They put this up for comparatively pennies. If they had to put this up back in the shuttle days, forget about it. With cheaper access to space comes riskier missions. As long as there's no human lives involved, sure. Send it out there with whatever wacky idea you can come up with and see what sticks.
That wraps it up for this week's Hackaday podcast. Thanks tons for listening. If you want to check out the links or join in the conversation, head on over to the show notes, hackaday.com/podcast. If you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
keep on hacking.
Well, that then... sound, music. Oh, we should get listeners to submit sounds and not tell us what they are.
I like it and I hate it at the same time.
True.
Okay, let me see here. So I have no segue for this, so I'll just start. Yeah, we don't need no stinking segues. So my quick... What? I said the same thing twice. I gotta say first. The order of words is important. I'm having an aneurysm. Do you smell... Anybody else smell toast?
That's it. That's a wrap.